Welcome to an application of game theory to the sport of cricket. Cricket is a bat and ball game consisting of two teams of 11 players, with the aim being to score the most runs as a team. In order to apply game theory to cricket, we need to make several assumptions and simplifications. We will only be focusing on one ball from within a match, rather than the hundreds that actually occur. We will focus only on two players, the bowler and the batsman at which he is bowling. It will be presented as a normal form game, meaning the actions of both players are simultaneous, a fair assumption given that both actions occur within a split second of each other in a match. We will assume there is perfect information, where both players know all actions available to both players and their respective payoffs. For the two players, we will assume that both can play one of two strategic actions, attack or defend. For the batsman, this means either playing an attacking shot, as you can see on the left, aiming to score runs, or a defensive shot, as on the right, aiming to not get out. For the bowler, attack means attacking the batsman to get them out, as on the left, whereas defend means stopping them from scoring runs, as on the right. These actions can be presented in a 2x2 matrix, with utilities assigned to each action for each player. The utilities here are not in terms of runs scored or lost, but are in terms of personal utility of that player. The logic behind the payoffs is as follows. Suppose that a bowler bowls an attacking ball. If the batsman attacks an attacking ball, we're assuming that he gets out every time, giving the bowler utility 1 and batsman -1, as you see in the top left box. If he defends it, however, he will never get out, and gains a utility of 1, whereas the bowler has failed to get him out, so he gains -1. Similar logic applies to the bowler if he chooses defend. Defend for the batsman means he has missed an opportunity to score runs, as the bowler was not trying to get him out, hence he gets -1 utility, and the 1 for the bowler. If the batsman chooses attack when the bowler chooses defend, however, he will score runs and the utilities switch. The game now resembles that of matching pennies game, where there are no pure Nash equilibria. This is because no single pair of actions from which neither player would want to deviate, so players' actions are uncertain. For example, at defend, the bowler would prefer to deviate to attack. The solution is therefore found by computing a mixed strategy, which is a probability distribution over some or all actions in pure strategies, giving the probability of a player choosing each action, so the other player is indifferent between their actions. Firstly, we assign probabilities to the actions P and 1 minus P for the bowler, and Q and 1 minus Q for the batsman's actions. We then calculate the expected payoff from each action for each player, and equate the two, to solve for P for batsman and Q for the bowler. As you can see, solving for P gives 0.5 probability, meaning if the bowler plays attack with probability 0.5, the batsman will be indifferent between attack and defend. The same can be seen for the bowler's expected payoffs, giving Q equal to 0.5, so an attacking shot from the batsman at probability 0.5 makes the bowler indifferent between attack and defend. Therefore, the mixed strategy profile in this game for the batsman is 0.5 attack, 0.5 defend, and for the bowler 0.5 attack, 0.5 defend. We have learnt therefore that both players are equally as likely to play attack as they are to play defend, and in equilibrium both players should randomise their attack and defend.